All let's see these three problems back to back on conic section, and we can solve all these problems in one line, and that's a beautiful way of problem solving. Usually the problem that a student faces in conic section is the length of solutions. So if you imply proper technique, it can be done in a good way. Consider ellipse E, x square by 9 plus y square 4 equals 1. S1 S2 is given as focus. A line with slope 1 by 36 passing through S1 meets C at P and Q, tangents drawn, meets in a point R, then x naught square is. So the first step in problems of conic section is to draw a neat and clean diagram. So we have two focus, S1 is focus number 1 since alpha is positive, and S2 is with negative x coordinate. Line with slope 1 by 36 passes through S1, meets ellipse at point P and Q, and we have to draw tangents at P and Q. They meet at some point, let's say x naught comma y. So now you can clearly see with respect to the point R, PQ is nothing but chord of contact, right? And this PQ should pass through focus, so E comma 0. Since I can write the equation chord of contact is T equals 0, that gives you x naught by 9 plus y naught by 4 equals 1, and this should pass through x equals E and y equals 0. So that gives him value of x naught as 9 by E. Right now, what is A over here? 3. So it will be 3 by E. The value of eccentricity is root over 1 minus p square by a square. It's 4 by 9. And that gives you root 5 by 3. So finally we have 9 by root 5 over here. So its whole square is 81 by 5. So option D is the correct answer for this problem. Let's try another one. Line with slope m passing through point 1 comma 0 cuts parabola y square 4x. Observation is 1 comma 0 is focus of parabola. So this line passes through focus. It cuts parabola at PM and QM, where m is the slope of this line. Tangents drawn at parabola to PM and QM meets at point RM for a given slope. Let HM be orthocenter of this triangle PQ, QM and RM. So we need to find the position of this point with respect to these curves. तो यहाँ पे फिर हम देख सकते हैं with respect to RM, this PMQM is chord of contact, and chord of contact is passing through focus. So this is focal chord. Now since this is focal chord, hence RM must lie on directrix. Now what is directrix of this parabola? X equals minus. It means no matter what focal chord you do, the point of intersection, even if slope changes, will always be constant to lie on this line. So all these 4 points, in fact infinitely many points for any m belongs to real number, will happen to lie on a line. So it was also a problem from t equal to 0, which is chord of contact. Let's try third one. Consider a curve represented by the equation in the plane so that normals to the curve drawn at 5 distinct points. We have some random curve, let's say, and if I take 5 distinct points here, normals drawn at all these 5 points meets at origin 0 comma 0, then the value of this. Now if we have 5 distinct points p1 p2 p3 p4 p5, let's see for this second degree curve, is it possible that they meet at single point? Now clearly if you will see parabola, so the equation normal in slope form is mx minus 2m minus m cube for y square equals 4x, and if it has to pass through 0 0, we'll have maximum 3 possible value of slope. So we can't have 5 distinct points. So maximum number of conormal points will be 3 for parabola. Similarly for ellipse, if we see the equation a square x by x1 minus b square y by y1 equals a square minus b square. So if it has to pass through, let's say, origin 0 comma 0, even a general equation, we can take a secant theta and b tan theta. So maximum will get 4 possibilities because it will be a biquadratic in tan theta by 2, right? So hence even for ellipse we can have maximum number of 4 normals. Now what are the possibilities for the second equation is hyperbola. So for hyperbola we'll have just plus sign, that will also give maximum for all possible normals. So now you are left with a straight line. So in a straight line we can't have conormal points here because maximum 2 conormal points can be drawn here, right? So the final answer for this is it has to be a circle, because if you have more than 4 conormal points, that means if you have more than 4 points from where the normals drawn is meeting at a point, it has to be circle equation because there is no other way, right? So it is a circle with center 0 0 and radius r, hence equation has to be x square plus y square equal to r square. तो यहाँ से the only possibility is h has to die, a and b has to be equal, and AC has to be less than 0, then only you will get a real circle. So in that way h is 0, so the answer for this question is just 0. So the third one was a conceptual question जहाँ पे you need to know maximum possible normal to parabola is 3, for ellipse hyperbola it can be 4, for circles it is infinite. So definitely its circle is the only curve which can satisfy this given constraint. Although you can start by writing the normal equations at a variable point x1 comma y1, okay, and taking 5 distinct point you can show you will get h0 and a equal to b, and AC or BC will be less than 0. If you want to engage yourself with more problem solving of this kind, please like and subscribe the channel to keep throughout your preparation. You'll get quality content for free over here. Thank you. Have a good day.